Hey guys, this is your example problem or problems for Newton's second law. Um, you could title it Newton's second law example problem, but then I would just want you to write down two problem solving steps after that. Just so you know, every time you do a problem with Newton's second law, you've got to do these two things. You got to sketch a force diagram first. That's the box with the arrows on it, and then you've got to calculate using Newton's second law, but don't calculate before you draw a force diagram. All right, force diagrams are required for every problem to get credit. All right, so let's read the first problem together and solve it. It says a box is pushed forwards at a constant velocity on a carpeted surface. The pusher uses a force of 10 newtons. It says calculate the force of friction acting on the box. So there is a push and there is a force of friction, those two forces acting on the box. Let's draw our force diagram with those two forces acting on the box. Our force of push, which is in the direction the box is moving. So I'm going to write V to the right. That's the way the box is moving. The push is 10 newtons. And they want us to calculate the force of friction on the box. It's pushed at a constant velocity, so I'm going to write constant. Whenever the velocity is constant, I'm going to indicate that on the next to the force diagram as well. So now that we've drawn our force diagram, I just want to point out a couple things. Every force gets a letter F, whether you know the number for it or you don't. So if you know that the push is 10 newtons, don't just write 10 newtons. Write FP equals 10 newtons. Then you have a full force diagram. If you don't know the force of friction and you're trying to solve it, don't not write it on the box. If there's a force you're looking for that you're not sure, it's your unknown force, then write that on the box in the proper direction. In this case, friction, always acting against the way an object moves, still is applied to the force diagram. But when it's unknown, just write that FF for friction equals question mark. All right. So one thing we know, when something moves at a constant velocity, we're going to use Newton's second law. F net equals ma, right? And we could kind of get F net here, get that statement going, but we're going to need to know that to solve this problem. So when something moves at a constant velocity, what is its acceleration? You should be able to answer this. It's no acceleration, 0 meters per second squared, when an object moves at constant velocity, or stays at rest. Would be another case when it has no acceleration. So we know the mass of our box, we can plug that in, 5 kilograms. We know when it's moving at constant velocity, there's no acceleration. And instead of writing F net, I'm going to write a statement for F net every time. Alright, so I don't know what the net force is, 10 minus question mark. I really don't know. I can't get an F net. But what I could do is say that the F net equals 10 newtons minus our missing force, the force of friction. Friction is a negative because it's acting opposite the way it's moving, while this would be a positive 10 newtons to the right in the direction it is moving. And this is what you're going to do every time. Instead of writing F net equals some number, you're just going to add up the forces, because what is a net force? It's the sum of all the forces. So you're going to always replace F net with some combination of forces that are on your diagram every time. Okay, so 5 times 0 equals 0. 10 minus FF. And we could see here that 10 minus what equals 0? 10 minus 10. So I'll just indicate that the amount of friction you have is 10 newtons. The direction is negative 10 newtons. So we can add that negative just to say that the direction is a negative direction. And these forces are balanced. It's positive 10, negative 10. That's why we get no acceleration. We stay at a constant velocity. All right. Continuing. On the same carpeted surface. So same surface. What does that mean? We know that if it's on the same surface and it's the same box, it has, again, the same force of friction on it. So we could write that there because it's the same surface. On the same carpeted surface, now the box is pushed with a force of 12 newtons. Alright, so we're going to say Fp, I know, is going to be 12 newtons. I'm just going to write that on the side as I'm reading. Calculate the acceleration of the box. So, before we calculate, we're going to draw our force diagram. Fp equals 12 newtons. Alright. Ff still is the negative 10 newtons. Okay. And then we could say, we could calculate our acceleration of the box. We could see that this acceleration, 12 is bigger than 10, so I'm going to get a positive acceleration. What is that positive acceleration going to be? We could calculate it using Newton's second law. So 12 minus 10 gives us the net force. Mass of the box is still 5 kilograms, same box. And we could calculate A. 12 minus 10 is 2. 2 equals 5A. Divide both sides by 5, and you've got 0.4 meters per second squared. And you can see it comes out as a positive because the box does speed up when the push is greater than friction. So that's number 2. 2 more extensions on this one. How about now? The third situation you're going to have to be able to do, besides constant velocity was number 1, positive acceleration was number 2. What happens when an extra push is applied? So there's one person pushing and then there's another person pushing in the same direction. So it says an extra push is applied to the box in addition to the 12 Newton push. So 12 Newton push is still there. Now there's another person pushing next to them. Box is still on the carpeted surface. What does that mean? Same surface, same amount of, you guessed it, friction. The box begins to accelerate at a larger rate, alright, I'm going to write positive 1.2 meters per second squared, alright. When the larger push was applied, calculate the force of the additional push, right? So we know that there's still that first person. I'm going to write FP1 now, since there's 2 pushes. We know FP1 was 12 newtons, but we're going to be looking for what we're going to label as FP2. Right now, that second person pushing, how hard are they doing it? Like always, you must read the situation and draw a force diagram. FF is negative 10. FP1 is positive 12. FP2 equals question mark. And we're going to indicate the acceleration next to the diagram. It doesn't go on the diagram because acceleration isn't a force. And then we can use Newton's second law to calculate how hard that second push is. Alright, so F net, add up all the forces, that's your F net. FP, I'm just going to write the FP's in there because before I put numbers in. All the right ones are positive, all the left is negative. Because we hate lefties. No, my brother's a lefty. Just kidding. And the A, we could plug that in, positive 1.2 meters per second squared. Alright, so I'm looking at that. I know these two are positive and the negative friction. And I'm just going to plug in my positive 12. Right, I know FP1 is 12, but now you just got to do your algebra to find FP2. 5 times 1.2, 5 times 1 is 5, 5 times 0.2. Let's do that on our calculators, 5 times 1.2. Six. Alright. 6 equals 12. Oh, we could also plug in friction, right? We knew we're on the same surface, so friction was negative 10. 12 minus 10 is 2. 2 and a positive FP2. Bring it down. Before we finally get FP2, all we got to do is subtract 2 from both sides. Alright, and 6 minus 2 is 4. So I'm just going to bring it right over here. FP2 equals 4 newtons. So that's how to solve for an unknown force there. Now you could do that. Not just calculate acceleration, but solve for F, or for some FP something. Okay, last one. All pushes are released from the box. So we had FP1, bye-bye. We had FP2, no longer there. Is friction exist if all pushes are released from the box? Yeah, friction still exists, alright? If the box is still moving, you're pushing it, it's moving along the carpeted surface. As long as it's still sliding, it's like friction. It's like that person we mentioned on the slip and slide, or a runner sliding into second base. If they're going and moving along the ground, there's still a friction force, alright? But nobody's pushing them anymore. Nobody's pushing this box. So friction, it's just slowing this box down at this point. FF is negative 10, alright? And it wants us to calculate, since friction is just slowing down, what is that negative acceleration of the box? At what rate is it slowing down? So after you draw your force diagram, there's only one force on the box now because there's no pushes. The net force would just be, it's the sum of all the forces, but when it's the sum of just one force, it becomes pretty easy. It's just negative 10. The mass of the box is the same. And calculate that negative acceleration. Just divide both sides by 5, and the box would slow down at a rate of negative 2 meters per second squared. See, when there's a negative net force, you get a negative acceleration.